Hi friends, now let's begin with what we had left yesterday. Yesterday we were discussing about the factors which are affecting the velocity and direction of wind. Okay, in that we had discussed about the pressure gradient force, the frictional force and the Coriolis force. The next factor affecting the variation and direction of wind, velocity and direction of wind is the pressure and wind. Okay. So the velocity and direction of wind are the net results of the wind generating forces in the upper atmosphere 2 to 3 kilometers above the surface, are free from frictional effect of surface and are controlled mainly by the pressure gradients and the Coriolis force, because there doesn't exist any kind of internal force of the earth. So we have the rotational force created created through the Coriolis force, and the pressure gradient force, okay, at a certain height from the surface of earth. When the isobars are straight and when there is no friction, the pressure gradient force is balanced by the Coriolis force and the resultant wind blows parallel to the isobar. This wind is called as geotropic wind. Isobars are those locations which have a common pressure. Okay, when the isobars are straight, if we are just mapping them, and when there doesn't exist any kind of friction, pressure gradient force gets balanced by the force created by the rotation of the earth, that's the Coriolis force, and the resultant wind blows parallel to the isobar. Okay, as you can see in the figure, in the northern and southern hemisphere we have these kinds of configurations. Okay, that wind generated is called geotropic wind. So the wind generated because of the counterbalancing of the Coriolis force and the pressure gradient force generates a different kind of wind called geotropic wind. Okay, this may also lead to the variation in the velocity of wind on the surface of earth. The wind circulation around a low cycle is called as a cyclone circulation. The wind circulation around a low pressure is called cyclonic circulation. We know cyclones occur mostly because of the creation of the low pressure belts. Okay, so the wind circulation around the low pressure belts are called as the cyclonic circulations or simply the cyclones, and vice versa around the high pressure belts we have the anticyclonic circulation or the anticyclones. Okay, and the directions of wind around such systems change according to the location in the different hemispheres. The wind circulation at the Earth's surface around low and high are closely related to the wind circulation at higher level, and over low pressure area the air will converge and rise. Over the high pressure area the air will subside from above and diverge at the surface. Some eddy currents, then eddies, or the convection currents, orographic uplift and uplift along the fronts cause the rise of the air, which is essentially in the formation of clouds and precipitation. Okay, convection current, orographic uplift because of the mountains and every kind of other landforms of higher altitudes on the earth. They also create the formation of different kind of wind because of the rising of air leads to the formation of clouds and finally precipitation. Now the next topic is the general circulation of atmosphere. Okay, The pattern of planetary wind largely depends on the winds depend on the latitudinal variation of atmospheric heating, emergence of pressure belts, migration of belt following apparent path of the sun, distribution of continent and ocean, and the rotation of earth. So we'll be discussing all these subtopics step by step. Okay, yesterday we had just studied about the different kind of pressure belts, okay, on the earth's surface, and their latitudes also, latitude variations also. From 0 degree to 5 degree north and south we have the equatorial low pressure belt. From 5 degree to 30 degree north and 30 degree south we have the subtropical high pressure belt. After that, from 30 to 60 degree north and south of the hemisphere we have the subpolar low pressure belt, and above all in the polar areas, polar regions above 60 degree north and 60 degree south till the tip, till the poles, north and south pole, we have the polar high pressure belts. Okay, the air at the intertropical convergence zone ITCZ rises because of the convection caused by the high insolation when low pressure is created. The wind from the tropics converge at this low pressure zone. ITCZ is the zone which is very nearer to the equator, intertropical convergence zone. The name only suggests the tropical location of the wind direction flowing mostly in the tropical region, constituting the equator also, equatorial region also. And in this paragraph, whatever we had discussed just before about the latitudinal variation and the pressure variation has been discussed over here. Okay, and few terms are there which are quite important. It's Hartley cell and Ferrel cell and all these. Let's see what are they. The easterlies from either side of the equator converge in their intertropical convergence zone. Winds coming from the eastern hemisphere, the circulations from the surface upward and vice versa are called cells. Okay, circulation of the easterlies from either side of the equator converge in the ITCZ. These are called as cells, and such a cell in the tropics are called as Hartley cell. The wind blowing in the tropical region, okay, constitute the Hartley cell. We have the circulation from the surface upwards and vice versa. In the tropics, in the middle latitude, the circulation is that of sinking cold air that comes from the poles and rising warm air that blows from the subtropical high. At this surface, these winds are known as the westerlies, and cell is known as the Ferrel cell. At the polar latitude and the cooler denser air subsides near the poles and blows towards the middle latitude. As the polar easterlies, this cell is called as the polar cell. These three cells set a pattern for the general circulation of atmosphere. The transfer of heat energy from lower latitude to higher latitude maintain the general circulation. Okay, so these are the three media of wind blow in the polar, equatorial and subpolar areas. Okay, in the tropical areas we have the Hartley cell, which constitute of the wind flowing in that area, mostly the easterlies. In the subtropical we have westerlies called the Ferrel cells, and in the polar easterlies we have the polar cell. wind blowing in the polar belt. So this was about this ITCZ and all. And next we have the general atmospheric circulation and its effect on ocean. Warming and cooling of the Pacific Ocean is most important terms of general atmospheric circulation. The warm water of the Pacific Ocean slowly drifts towards South American coast and replaces the cold Peruvian current. Oh, this is about El Nino and La Nina. Okay, so uh, in the southern hemisphere, in the South America actually, in the leftmost part of South America, we have one region, one country called Peru, and around that the Peruvian current is actually blowing. Okay, so when the Pacific Ocean water warms and cools, the when the warm water evaporates, okay, then that warm water of the Pacific Ocean, warm water vapor, uh, drifts along with the wind blowing there, okay, and they drift towards the South American coast and replaces the cold Peruvian current. Cold Peruvian current, as I stated you, that the air pressure and the current just above the location of Peru, okay, South American western uh, part of the South America, okay, so that Peruvian current gets replaced by the warm water of the Central Pacific Ocean, okay, warm water vapor actually, and this replacement of the warm water of the Central Pacific Ocean towards the cold Peruvian current causes El Nino. Okay, this is occurring on the coast of Peru. So this is a very simple concept. When the Pacific Ocean uh, gets heated, the warm air created because of the evaporation, okay, rises, drifts towards the left and replaces the cold Peruvian current present on the western side of the South America above Peru and other countries. So this causes El Nino effect. The El Nino event is actually associated with the pressure changes in the Central Pacific and Australia. A change in pressure condition over the Pacific is known as the Southern Oscillation. The combined phenomena of Southern Oscillation and the El Nino is called ENSO. Okay, the pressure gradient in the Central Pacific and Australia is the event which is closely associated to El Nino, and the change in the pressure condition over the Pacific is called as the Southern Oscillation. Okay, Pacific mostly found in the southern hemisphere only. Okay, so that's the name has been given the Southern Oscillation, and the combined phenomena of the Southern Oscillation and El Nino, as we had stated just before, is called as ENSO. Okay, these are quite important from the exam point of view. They can ask you about the basic characteristics of ENSO and El Nino, what happens actually. Okay, the so you should have a clear concept about this. Now we have the seasonal winds. The pattern of wind circulation is modified in different seasons due to the shifting of region of many maximum heating, pressure and wind belts. The most pronounced effect of such a shift is noticed in the monsoon. Okay, and monsoon, as we had said, we had discussed. I don't think we have discussed in detail. Monsoons are actually the creation of low pressure belt on the Indian subcontinent and regions. Okay, and they emerge into the country in June first week. mostly 1st to 3rd of June they enter into India through Kerala coast. Okay, and after that within 10 to 15 days they cover up the entire Indian subcontinent. Okay, so this is about concept called monsoon. This is a seasonal wind actually, and this also causes the variation in the velocity of the wind. Before monsoon we have the slow moving wind, but when the monsoon emerges we have a sudden change in temperature which also follows the fast movement of the wind and the rain and every kind of storm and all the various environmental changes which we have observed. Okay, then we have the local winds. Difference in the heating and of cooling of earth's surface and the cycles those develop daily or annually can create several common local or regional wind. One local wind we had just explained you yesterday about the Loo. That's also local wind which is being most common in the North India and most common in most parts of India also. Those places which are having a very extensively high wind blow in those areas which have less uh, moisture in the air and rainfall is also less. In those places we have seen these kinds of extremely high wind blow called as the Loo. These are the local winds. Okay. So they also are responsible for changing the variation, bringing variation and changes in the direction and velocity of wind. Okay. Now we have the sea breeze and land breeze. We had also discussed it few days back about the sea breeze and land breeze. We'll just discuss them again. Okay. The places which are very near to the seas and ocean, the land masses, for example the coastal areas which are very near to the land, to the seas and oceans, and due to the during the daytime when we have the sun rays and maximum insolation of the day, then these insolation lead to the evaporation of the water of the seas and ocean. Okay, however the intensity of evaporation is less because of the less intensity of insolation being occurring on the surface of the sea than the earth. Okay, because of the maximum insolation of the sun on the surface of earth, the earth has a tendency to get heated faster than the sea, and when the land masses or the coastal regions, the continent part or the land part of the earth actually gets heated faster than the sea, then it creates a certain low pressure belt over its surface. Okay, so a low pressure belt is being created, low pressure area actually is being created uh, over the surface of land. Okay, low pressure area means low pressure air, air pressure becomes low over here. Okay, over the surface of land because of the constant heat being reflected from the surface of land because of the maximum solar insolation. Okay, now the seas and oceans near to the landmass will also get heated, but the intensity of being heated would be low. Okay, would not be heated as faster and as intense as the land masses following them. Okay, so they would, the sea and ocean will also, water will also get heated and will try to evaporate. Okay, and high pressure would be created on its surface. Okay, on the surface of the seas and ocean. as we know that wind tries to follow a path from high pressure area to a low pressure area. So that wind which is just present over the surface of the sea, that's actually a part of the high pressure zone, will be following the low pressure zone which had been already been created over the landmass due to the higher solar insolation. Okay, so this travel of wind from a high pressure region just above the sea and ocean to a lower pressure region just above the landmass following that ocean or region, ocean or sea, will be called as the sea breeze. Okay, that's mostly common in the daytime. Okay, and as the time will pass, the solar insolation and the sun rays, the sun radiation will try to get depreciated into intensity. Okay, and after that, what will happen? The scenario will be changing. Evening will be coming after a few hours. Okay, during the evening, when the sun is about to set, then the land will not get heated much. Okay, but the water of the sea will be heated more than the land. The scenario will again be different. Okay, opposite to that way what we have observed in the case of sea breeze. Okay, so what's there? The same scenario will be taking place over here. The water will evaporate from the sea. Okay, it will rise up, will be evaporating faster. Creation of low pressure area would be just above the seas and ocean, and adjacent to that in the land mass again the same scenario will be taking place but at a less intense level. Okay. The water will the land mass will also be getting heated, but not as much as being heated by the sea. Okay, yes. So the warm air will be creating the high pressure area over that, since a low pressure has been created over the sea because of the more intensity of evaporation and more intensity of heat. Okay, so a high pressure would be created over the landmass, and this time the air will be trying to follow a path from land to the sea, that is from a pressure of high pressure area to a low pressure area. Okay, so this phenomena is called as the land breeze, when the wind tries to follow the path from land to the sea because of the creation of high pressure belt over the landmass and the low pressure belt over the sea. So this is the phenomena which causes a variation in the air and wind direction and velocity, okay, during the day and night because of the phenomena of land and sea wave. So this is a very basic kind of thing which everyone should know, quite important from the competitive exam and UPSC point of view. Important in other exams also, state PSCs and other kind of exams. Now we have mountain and valley winds. Okay, in the mountain regions we have observed that the valley is actually V-shaped. Okay, surrounding the mountains, below in between the mountain we have a kind of V-shaped valley. Okay, during the day the slope gets heated up and the air moves up slope, and to fill the resulting gap the air the valley blows up the air from the valley blows up the valley. Okay, so during the daytime when the valleys get heated up, then air moves slope on the slopes of the mountains, and the air from the valley blows up the valley. This wind is called as the valley breeze. During the night, the slope gets cooled and the dense air descends into the valley as the mountain winds. The cool air of the high pressure plateaus and ice fields draining into the valley is called a katabatic wind. Katabatic wind is observed in the night when the slope gets cooler and the dense air descends into the valley as the mountain wind. The cool air of the high plateaus and ice draining into the valley is called as the katabatic wind. So another type of warm wind occurs on the leeward side of the mountain. Okay, leeward side is that side of the mountain which is receiving rainfall. Okay, moisture in these winds while crossing the mountain ranges condense and precipitate. When it descends down the leeward side of the slope, the dry air gets warmed and by the adiabatic process. This dry air melt the snow in short time. So when the air gets heated in the day on the surface of the slope of the mountains, the warm air tend to rise on the slope. Okay, and during the evening, the or even in the night, the slope gets cooled and the dense air descends into the valley as the mountain wind. The cool air of the high plateaus and ice called as the katabatic wind. Okay, and the warm air which we had just seen in the morning in the daytime rising up the slope of the mountains, okay, in the form of warm air, that was called as the valley breeze. And at the night, uh, the cool air, okay, of the slope descends into the valley as the mountain wind, which is called as the katabatic wind. It is similar to the phenomena of land and sea breeze. Land and sea breeze were found mostly in the coastal areas and the places where we have a source of water adjoining our landmass. Similar is the case over here. Valley breeze and katabatic wind are two kinds of wind which are erected because of the seasonal change in the solar insolation at the day and night. Okay, during the day we have see that the slopes get heated faster, and that's why warm air, dense air blows down the slopes. These are called as the mountain breezes or the valley breezes actually. Similar is the case when the sun sets, the solar insolation decreases, so the cooler air gets into the valley, descends into the valley as the mountain wind. This cooler air of higher plateaus of ice trailing into the valley is called the katabatic wind. Okay, so it is quite similar phenomena as we had studied before in the land breeze and sea breeze. Now comes the air masses. Air masses are actually the volume of air which are constituting particular locations, particular continental locations, okay, from where they originate. Okay, it's called as the source region. Five major source regions, they are warm tropical and subtropical ocean, the subtropical hot desert, the relatively cold high latitude ocean, the very cold snow covered continents in high latitude, permanently ice covered continents in Arctic and Antarctic. Okay, five types of air masses are recognized: maritime tropical, continental tropical, maritime polar, continental polar, continental arctic. Okay, so these are the source regions, warm tropical and subtropical oceans, which create as a different kind of wind. And subtropical hot desert also create a different kind of wind, which is quite high, warm, and dense, and actually hot. The relatively cold higher latitude ocean, which create a cooler kind of wind blowing. The very cold snow covered ocean in the latitudes, they also, you know, create the chilling kind of wind because of the snow covered continents and permanently ice covered oceans in the Arctic and Antarctic. Okay, they also have a different kind of wind blow, but actually no wind blow actually flow in the Arctic and Antarctic because of the permanent ice covered. Okay, breezes, cold breezes are blowing in those areas which are extremely cool, and they may be having a temperature in negative. So these kinds of source regions create this formation of these kinds of air masses above those places which have been classified in these maritime tropical, continental tropical, maritime polar, continental polar, and continental arctic. These are the types of air masses. Now we have the fronts. Okay, when two air masses meet, the transition zone in between them is called the front. Okay, this process of formation of front is known as frontogenesis. Four types of fronts: cold, warm, stationary, and occluded. When the front remains stationary, it is called as a stationary front. When the cool air moves towards the warm air mass, the contact zone is called as the cold front. When the warm air mass moves towards the cold air mass, the contact zone is called as warm front. If an air mass is fully lifted above the surface of land, it is called as occluded front. The front occur in the middle latitude and are characterized by a steep gradient of temperature and pressure. They bring abrupt changes in the temperature and cause the air to rise from the cloud and cause precipitation. So it's about the front, which is actually a meeting point or a boundary point between two air masses. Okay, so air masses when meet at a transition zone, they create a front. Okay, this process is called as frontogenesis. Four types of front: cold, warm, stationary, and occluded. When the front remains stationary, they are called as stationary front. When the cool air moves over the surface of warm air, then they are called as creation of cooler front, cold fronts actually. When the warm air mass moves towards the cold air mass, the transition zone or contact zone is called as the warm front. If an air mass is fully lifted above the land surface, it's having a transition zone above the land surface. It's called as the occluded front. The front occur in the middle latitude and are characterized by steep gradient in temperature and pressure. They bring abrupt changes in the temperature and cause air to rise from clouds, cause precipitation. Now we have the concept that fronts are responsible for causing rainfall and changes in the variation of temperature. Obviously it will happen because of the transition zone has been created by the warm and cold, similarly with the cold and warm ocean currents. So these transition zones cause variation in the temperature, which finally creates the fronts, and fronts eventually are responsible for the cloud formations and precipitation kind of phenomena. Okay. Then we have the extratropical cyclones. Extratropical cyclone are the system developing in the mid and high latitude. Okay, beyond the tropics are called middle latitude and extratropical cyclone. The passage of front causes abrupt changes in the weather conditions over the area in the middle and high latitude. Extratropical cyclones form along the polar front. Initially, the polar is stationary. In the northern hemisphere, the warm air blows from south to south and cold air from the north of the front. When the pressure drops along the front, the warm air moves northwards and the cold air moves towards the south, settling the motion and anti-clockwise cyclonic circulation. The cyclonic circulation lead to the well-developed extratropical cyclone with a warm front and cold front, plan and cross section. The process of wind circulation both at the surface and soft are closely interlinked. The extratropical cyclone differs from the tropical cyclone in a number of ways. The extratropical cyclones have clear frontal systems which are not present in the tropical cyclones. Okay, this is about the extratropical cyclones, which are mostly generated due to the creation of high pressure belts in the high latitude areas, middle latitude and extratropical cyclones. The passage of front causes abrupt changes in the weather condition over the area in the middle and high latitude. Okay, so one most important thing about this is the difference between extratropical cyclone and the tropical cyclone. This may be asked in the examination. So let's understand this. The process of wind circulation both at the surface and aloft. Extratropical cyclones have a clear frontal system which is not present in the tropical cyclone. So frontal system means a transition zone has been created by the two characteristics of the air, whether it is a warm or a cold, or whether it is a cold or a warm, whether it is a polar or a subpolar kind of wind. Okay, so a transition zone has been created in the anti-tropical cyclones. So anti-tropical cyclone support the frontal systems, but the cyclonic waves do not. Cyclones do not. Tropical cyclones do not. Okay, obviously the anti-tropical cyclone will be extratropical cyclones will be having a large extent of area than the tropical cyclones. Okay, tropical cyclones originate only over the sea, and on reaching the land they dissipate. The extratropical cyclone affects a much larger areas compared to the tropical cyclone. The wind velocity in tropical cyclone is much higher and it is more destructive. Extratropical cyclone move from west to east, but tropical cyclone move from east to west. So what's the difference between the extratropical cyclone and the tropical cyclone is that extratropical cyclone support the transition zone being created by the two air masses. Precisely, we can say that extratropical cyclones support the frontal systems. The tropical cyclones do not support the frontal systems. Extratropical cyclones have a large extent of area being covered. The tropical cyclones have a lower extent of area being covered. The tropical cyclones are more destructive and the wind speed is more than that of the extratropical cyclone. Okay, extratropical cyclones move from west to east, but the tropical cyclone move from east to west. So these are the basic differences between both extratropical cyclone and the tropical cyclone. These are important from the exam perspective. A question may be framed about the characteristics of these two, and you may be asked to match them, or you may be asked to eliminate the options and correct the multiple options type of questions. Okay, so there shouldn't exist any kind of confusion in attempting these kinds of questions. These are quite basic and quite easy to understand. Difference between the extratropical cyclone and the tropical cyclone. Okay, basic characteristics are being discussed over here. Now comes the tropical cyclones. They, as I said, told you that they are violent storms because of the high speed, high velocity. Okay, originate over the oceans in the tropical areas and move over the coastal areas, bringing about large-scale destruction caused by the violent wind, very heavy rainfall, and storm surges. This is one of the most devastating natural calamities, called as cyclones in Indian Oceans, hurricanes in the Atlantic, typhoons in the Western Pacific, and South China Sea, Vili in the Western Australia. These nomenclatures are important. Okay, from the exam point of view, so you may just remember them. Cyclones in the Indian Ocean, hurricanes in the Atlantic, typhoons in the Western Pacific, Southern China Sea, and Vili in the Western Australia. Vili WW, so it's prevalent in the Western Australia. W for Vili, W for Western Australia. Okay, hurricanes you might be having an idea. Okay, because hurricanes are found mostly in the Atlantic Ocean and the regions near the United States and all. So hurricanes and cyclones won't be having a problem in remembering. Vili is also quite similar. W stands for Vili and W stands for Western Australia. One thing you have to remember is typhoon is found mostly in the Western Pacific and South China Sea. South China Sea is a very long stretch of ocean and sea, okay, which primarily enters into the Pacific. Okay, so if you would be just having a rough idea of the entire globe, both the eastern and western hemisphere, could be finding out that southern China Sea entirely mixes into the Pacific, Western Pacific. So this typhoon also has an influence over there. Okay, hurricanes in the Atlantic Ocean, cyclones in India, we all know, and we live in the Western Australia. This nomenclature is quite important. Apart from that difference in the extratropical cyclone and tropical cyclone, this is also a very important concept, which is a favorite topic of the examiner who is going to set the question. Okay, so this nomenclature should be understood rather memorized. Nothing there is existing any such as to remember, as to understand the concept. It's quite factual, and you know have to memorize it anyhow. Tropical cyclone originated intensify over the warm tropical ocean. The conditions favorable for the formation of intensification of tropical storms are large sea surface with temperature higher than 27 degrees centigrade, which will be supporting the evaporation. Okay, the presence of the Coriolis force, as we said, that the rotation of the earth creates a different kind of force which causes front variation and air variation at various locations, called as the Coriolis force. A small variation in the vertical wind speed, as we know, doesn't have any effect on the wind movement, rather having a very smaller kind of effect, since we are just facing the horizontal only the wind. Okay, a pre-existing weak low pressure area. Low pressure area is a must for the creation of tropical cyclones. Okay, we had studied this before also. And low level cyclonic circulation, this is a must. And upper divergence over the sea level system. The divergence means the different kind of air being formed over the sea level system. There shouldn't exist any other kind of air. There should be a proper divergence, proper location where the proper space would be provided above the sea level system. The energy that intensifies the storm comes from the condensation process in the towering cumulonimbus clouds. Okay, now we have to study about the clouds. Okay, Its continuous supply of moisture from the sea, the storm is further strengthened. On reaching the land, the moisture supply is cut off and the storm dissipates. The place where a tropical cyclone crosses the coast is called landfall of the cyclone. The cyclone which crosses 20-degree latitude generally recur when they are mostly destructive. The place where the tropical cyclone crosses a coast. Okay, when the tropical cyclone has emerged and it has just landed a coast, that place is called as the landfall of the cyclone. Okay, because since it originated, it was just traveling with a very high speed in the atmosphere, but when it has struck the landform, that's the coastal area obviously, then that is called as the landfall of the cyclone. Means it has struck the ground, struck the place where the people are supposed to live. You can remember like this. Schematic representation of the vertical structure of mature tropical cyclone storm is shown in figure 10.10. So these are not important. You have to remember these terminologies. The eye of the cyclone is a region of calm with subsiding air. Around the eye of the eye wall, there are a strong spiraling ascent of air to greater height reaching the tropopause. The wind reaching maximum velocity in the region reaching a height of 250 kilometers per hour. So remember the speed of these cyclones more than 250 kilometers per hour. Okay. So eye of the cyclone is something which is called as the circulating wind around the center called as the eye. Okay, it's actually cyclones are moving in the spiral manner as we have seen in the photos and videos, and everyone I think must have seen the general image of a cyclone in newspapers and other media sources. So a mature tropical cyclone is characterized by strong spirally circulating wind around the center. Okay, that's called the eye. A very tiny center existing in between in the center of the cyclone, and that is spirally moving. The the diameter is not at all concentric. There are plenty number of concentric circles, okay, which just keep revolving, keep rotating actually around a particular axis. Axis actually imaginary. Axis is something which is just the eye. Okay, that smallest spiral circulating wind around the center, when the center of the cyclone is called as the eye. It's having a very broad base at the top and it has a extremely narrow base at the below. So that narrow base will be constituting of the eye of the cyclone. It is actually the center of the cyclone spiral. Okay, diameter of the circulating system can vary between 150 to 250 kilometers. Okay, this is about this. We see here subsiding warm air, undistributed wind, tropopause. Okay, steering wind flow, subsiding warm air getting into the cyclonic storm. Okay, and eye of the cyclone is at the center, which is just having a bunch of wind being blown at a very tremendously high speed. Okay, so this was about the cyclone, and now the chapter has ended. Now we have thunderstorms and tornadoes. Let's have a discussion on this also. Other several local storms and thunderstorms and tornadoes. Okay, thunderstorms are caused by the intense convection on the moist hot days. A thunderstorm is a well-grown cumulonimbus cloud producing thunder and lightning, and the cloud extends to heights where the sub-zero temperature prevails. Hails are formed and they come down as hailstorm. If there is insufficient moisture, a thunderstorm can generate dust storm. A thunderstorm is characterized by intense updraft of the rising warm air, which causes clouds to grow bigger and rise to great height. That's called as precipitation. Okay, so let's see what he's trying to say. The author is trying to say. Thunderstorms are the short duration occurring over a small area but are violent. Definitely it could be violent. Thunderstorm, the name only suggests. Caused by the intense convection of the moist hot days. A thunderstorm is a well-known cumulonimbus cloud producing thunder and lightning. It's actually a kind of cloud producing thunder and lightning. When the cloud extends to height where sub-zero temperature prevails, hails are formed. When the temperature decreases, and the hails are formed. Hails are actually the small kind of very small tiny kind of structures constituting of the ice actually, and other particles inside it. So they come down as when they strike onto the surface of earth, they are called as hailstorm. If there is insufficient moisture, a thunderstorm can generate dust storms. In the absence of any kind of moisture, the dust particles may also be a part of the thunderstorm, and a thunderstorm is characterized by intense updraft of rising warm air. Warm air is rising, which causes the clouds to grow bigger and rise to form the clouds, and ultimately precipitation takes place. Okay. So later downdraft brings down the earth and cooler air and the rain. When the precipitation occurs, then the cooler air and the rain takes place onto the surface of earth. From severe thunderstorms, sometimes spiraling wind descends like the trunk of an elephant with a great force and very low pressure at the center, causing massive destruction on its way. Such a phenomenon is called as tornado. Generally occurs in the middle latitudes, and the tornado over the sea is called as water spouts. These violent storms are the manifestation of the atmosphere's adjustment to varying energy distribution. The potential and heat energies are converted into kinetic energy in these storms, and restless atmosphere again returns to the stable state. So this is actually a cycle being repeated. Okay, atmospheric cycle being repeated. Sometime there will be chilling wind in the winters, then we will be having a spring kind of feeling when the plants will blossom, flowers will blossom, the sparrows will chirp, followed by the hot chilling summers. After that monsoon will come. Monsoon will bring all these kinds of thunderstorms, cyclones, hurricanes, tornadoes, everything around the globe. So these are the phenomena which keep changing in the seasonal cycle, and this is all about this. As we have studied about the thunderstorm, just similar is the case with tornado. Okay, tornado is occurring mainly in the middle latitudes, and they are also having the same phenomena of creation. Okay, but location is quite different. They are mostly found in the middle latitude. Okay, low pressure is a must, as I told you, for the creation of these kinds of phenomena, causing massive destruction on its way. So this was about this chapter. You should have a clear-cut idea about the questions which are being supposed to be asked in the examination. I just have give you a clear-cut idea about the questions which can be framed from this chapter. So next we will be dealing with the next chapter tomorrow. Okay, please like, share and subscribe to my channel. Thank you. If you do have any kind of comment related to this chapter or any kind of query, you may just comment down below. I will be happy to reply you. Thank you.